Okay, so when we're graphing quadratics, what we have to look at is it's very similar to graphing a line. We're going to start by just using a table of values. So a quadratic, so the graph of a quadratic is called a parabola. Okay, so a parabola. Okay, it's a U-shaped graph, and we're just going to use this table of values, and all I've done is started at -3 and gone up to 3. So I'm going to start in the middle here. If we do 0 squared, all we're doing is inputting into this equation, y equals x squared. 0 squared is obviously 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. Because of this being a squared graph, on the other side, we're just going to have 2 negatives every time. So it's going to be 1 squared again, 2 squared, and 3 squared. Because -1 times -1 is 1, two negatives make a positive, 4 and 9. Okay, so when we put this on the graph, if we just graph the positive side, so we'll start at 0, 0. That's actually called the vertex. That's a super important point, and you're going to need to know that. So the vertex of this graph is right there. Okay, it's 0, 0. Okay, and we're going to be moving the vertex and then graphing using what's called a point pattern. But if we go over 1, we go up 1. Now from that point, we're going to go over 1 and up 3. From that point, we're going to go over 1 and up 5. And what you should notice is the difference here was 1, this is 3, and this is 5. We're just increasing our difference by 2 each time. So if I needed to put another point, I'd go over 1 and up 7. Now again, due to the graph being a parabola, it's going to look the exact same on the other side. So when we go over 1, we go up 1, over another one, we're going to go up 3, and over another one from there, we're going to go up 5. Okay, you can always go back to your table of values, and it'd be 1, 4, 9, because we're just squaring the numbers. But our point pattern is going to be over, I'll write the word over, not just O. So we have over and up. And that's going to change based on some things that we do later, but we're going to go over 1, up 1, then over 1 more and up 3, then over 1 more and up 5. Okay, so our over and up, we're always going 1, 1, 1. We're always moving to the right one, and then we're going to do the exact same thing on the left, but we're going up 1, 3, 5. Okay, that's kind of the basis of a parabola, and what it's going to look like is something like this. Now, it's not a V, it's a rounded shape. Because if we were to actually square like 0.5, that would be 0.25. If we squared 0.25, that would be 0.0625 or something like that. No, it's going to be way smaller. Okay, so if we look at this, a parabola is symmetrical. Okay, it can be folded over itself, is what that little bracket there says. Okay, now an important thing is that it has an axis of symmetry. Okay, the axis of symmetry is always the x value of our vertex. Okay, so the axis of symmetry of a parabola is the reflection line that maps the parabola onto itself. For y equals x squared, the axis of symmetry is going to be x equals 0. Okay, it's always the x value of the vertex. Okay, and the vertex is always our starting point. Okay, y equals x squared opens up. The vertex is the lowest point. It's the minimum value in this case. And we're always going to be looking at the y coordinate when we're talking about maximum or minimum values. So for y equals x squared, the vertex is going to be 0, 0. It's our lowest point, okay, our starting value, where the minimum happens here at this value. Okay, so let's look at a couple examples here. So it says graph the following on the same set of axes using Desmos. We have y equals x squared, which if I were to graph that, it's going to look something like that. That's what we had on the last one. Then we have x squared plus 2 and x squared minus 5. So if we went to Desmos and did that, there's our y equals x squared graph. Now if I put +2, all it's doing is, if I zoom out, it's actually moving the exact same graph just up 2, which makes sense because it's y equals that value. Okay, y equals x squared, well, then we're just adding 2 to all of those values. Okay, if I did y equals x squared minus 5, well, it's moved the graph down 5 because we're subtracting 5 from our final y values. So when we're graphing that, when we come back over here, this is y equals x squared. We'll go to red and we'll do y equals x squared plus 2. Would be that. So that's y equals x squared plus 2. And then green can be y equals x squared minus 5. And all it's doing is changing our final y value, so it's moving it up or down. So how are the three graphs the same? They're all the same shape, okay? The only thing that's changing is our starting point. So they're different. They start, at different values. So we're going to say different vertexes. Whoa. Okay, so we've got that. Now, if we were to look at these values, we know that the minimum for y equals x squared, so use the minimum operations, write the vertex. Well, the minimum for y equals x squared, or the vertex, was 0, 0. We've already talked about that. The x value doesn't change for either of these. So we know that we have 0 and 0, because we haven't done anything other than move it up in the first case or down in the second case. Well, that also changes our minimum value. So this one would be 0, 2, and this one would be 0, negative 5. We've just moved everything up or everything down. Now the axis of symmetry hasn't changed either. It's always that line that we look at the graphs. Well, the axis of symmetry in each case here is just the y-axis. The y-axis happens at x equals 0. We haven't moved it left or right at all. So we have x equals 0 for all of them. So what translation maps this onto the graph? Well, really, the x squared plus 2 has just moved up 2. Or x squared minus 5 has moved down 5. Okay, we're talking about the y equals x squared graph. What did we do to it? We moved the first one up 2. We moved the second one down 5. So without graphing, write the coordinates of the vertex and the equation of symmetry for these. Well, I know that all of my values are going to have a vertex with a 0 for my x because I'm not moving it left or right. So this is going to be 0, and then I've moved the whole graph up 1, so it would be 0, 1. The axis of symmetry is just x equals 0. This one would be 0 because we haven't moved left or right, but we've moved down 3, so negative 3. This would be 0 and then down 7. And this would be 0 and up 8. All we're doing with that last value is moving the graph up and down. It doesn't change my axis of symmetry because we haven't moved left or right, and the graph is symmetrical left to right. So in conclusion, when we're looking at these graphs, if we have y equals x squared plus k, and k is greater than 0, we're moving up by k. If it's less than 0, we're moving down by k. And our vertex for both, the vertex for the first one, if it's greater than 0, would be 0 and k. The vertex for the second would be 0 and negative k because we've moved down. All right. So if we were to look at these three graphs, it says for each of the following, state the vertex and then graph. Okay, so we haven't changed our step pattern at all. So we know that our step pattern is going to be our over and up is going to be 1, 1, 1, and then we're going to have 1, 3, 5. Okay, so here my vertex would be 0 and 3. We've moved the graph up 3. So I'm going to go to 0, 3. Then I'm going to go over 1, up 1. I'm going to put a point. I would go over 1 more, up 3, put a point. Over 1 more and up 5, so I can't do that one. So I'm going to stop. I'd go the other way. Over 1, up 1. Over 1, up 3. And I would put my points. For these graphs, we want at least 5 points. So that would be good. And then I'm going to connect my dots. And when I connect my dots, I'm going to stop the graph pretty much right after my last points, because that's where I want to just put the arrows. That's signifying that the graph will go on like this forever, but we're going to stop right there. Okay, for the next one, we would have 0 and -6. We've moved down 6. So we would do the same thing. Start at -6, go right 1, up 1, right 1, up 3. And then this one, we could go right 1, up 5 if we really wanted to, make the graph nice. And then we're just copying it exactly on the other side. And then we're going to connect our dots. And we've got that. And then finally, we have 0, -1. Same thing. I'm just going to do 5 dots this time. Over 1, up 1. Over 1, up 3. Over 1, up 1. Over 1, up 3. And if you look, all of these graphs look the exact same. They've just been translated up or down.